Good morning, everyone. I hope you are all doing well. My name is Anusha, and I'll be your host for today's session. I'm excited to welcome you all to Introduction to React, Empowering Creativity with Front-End Innovation, organized by the Department of Computer Science and Engineering in collaboration with Coding Ninjas COIT as part of the course Front-End Engineering. Today, we are here to dive into the powerful JavaScript library, React.js, a tool that's shaping the way modern web applications are built. Whether you are a beginner in web development or someone keen on sharpening your front end skills, this session will give you a solid foundation to create dynamic and visually stunning web applications. Now it's time to introduce the expert who will guide us through today's session. It is my absolute pleasure to extend a very warm welcome to Mr. Yakshit Garg, our guest speaker. Mr. Garg is a software development engineer in test at Optmyzer and an expert in front-end development. His experience in creating dynamic and interactive user experience combined with his practical insights makes him the perfect person to introduce us to React.js. Welcome, Mr. Garg, and you all
Yeah,
may ask your questions in chat at the end of this session, and we will make sure they are addressed. Now, without further delay, let's get started. Over to you, Mr. Yakshit.
yeah. So, hello everyone, and thank you, Coding Ninja COIT chapter, for having me here today. So, yeah, I will be your expert for uh, giving you a session on introduction to React. So, basically, our agenda will be first to learn why, firstly, the language, the scripting language that we all know, JavaScript, is created, is developed, and how it's executed in the browser environment. So yeah, let me share my screen. So yeah, I hope the screen is visible. So let's get started with introduction to React, building interactive and scalable web application. So let's first understand why firstly JavaScript was developed and who developed it. So basically, uh, let's understand what is first of all Mocha. So Mocha is the original code name given to JavaScript, which is basically a lightweight object-oriented scripting language. So what happened is, in 1995 there was a company named Netscape, and Netscape aimed to develop this language, this scripting language for web developers and designers to create interactive web pages. So at that time, what happened is there is a person named Brandon Ike which joined Netscape in 1995, and he was the person who developed this language. So uh, what like why this name was given JavaScript? Like first of all, it was named as Mocha. Then why JavaScript was named after it? So what happened is there is another company named Sun Microsystems at that time, which created a programming language, another programming language you all know as Java. So Java was a little bit complex, and as it is a class based, so it is like a little bit complex for the designers and developers. So the company Sun Microsoft, Sun Microsystems, sorry, and Netscape came in an alliance and created this language named JavaScript. So first of all, it was named as Mocha, but as the alliance is formed, and as Java was the language which was in hype at that time, so they named it as its little brother kind of thing. So for the marketing stunts, they named it as JavaScript. So Java was too complex for web designer, they formed this simple scripting language which is basically object based rather than class based. So this is how the language that we all know, JavaScript, which is used in so many websites nowadays, is developed. So let's now understand what is a V8 engine. So as we all know, JavaScript requires a runtime environment to execute, and this runtime environment consists of a lot of parts that we have in our browser, and one of that is V8 engine. So what V8 engine is, and why it is developed. So back in 2008, Google made V8 engine for improving the web experience and to gain control over the evolution of web. And as we all know, Google Chrome is widely used today, and they were successful in their plans of creating a good user experience by creating this V8 engine. Originally, they use a normal WebKit layout engines and these kind of stuffs, but later on, with evolution of time, they added so many things in this engine, which helped like increase the user experience, increase the speed, and also is with the web standards that we all know we have. So let's understand what is a V8 engine basically is. So yeah, so let's understand this on this graph, this flow chart once. Let me explain the flow chart. So when you write a JavaScript code, when a JavaScript code is written and is being executed in the browser environment, what happens is, let me show you. So we have a this we can say a box-like environment, which is basically our environment. So this whole box is our JS uh, runtime environment. Okay, so now this environment has many parts of this, in which one is the our V8 engine. So this is our V8 engine, and we have something called as APIs here. We have APIs, V8 engine. Then we have a event loop. If you all know event loop, we will explain it later also. So we have this event loop. We have a callback queue, which is known as AST, which is an abstract syntax tree, and let's on the right hand side. So in this we have like, if we click here on tips variable, it happens is after that this syntax tree will go to the interpreter. So in V8 engine there is a interpreter also. uh, let's write his name also here. It's so the interpreter named is ignition. So Google named their interpreter, which is used in V8 engine, as ignition. Now, as this AST, the abstract syntax tree that we have of the code, goes to this ignition, which is an interpreter, this ignition will convert it into a bytecode, into bytecode. Now, as we know, this V8 engine converted this bytecode. So initially there was only interpreter in V8 engine, but as it was a little slow, because as we know interpreter is a line to line execution, so it first reads first line then goes to second in this way. So they also added a compiler to it. So they added a compiler in V8 engine, and it's named as turbofan, which is the main compiler. As we can say later on, a lot of things are added in this also. So what it does is this will take this bytecode, run some optimization here. So some optimization will occur. So optimization, you can say some optimization will occur, and as the turbofan optimize this code, we will get a optimize machine code here. uh, Optimize machine code, optimize code, basically machine code. So in this way, the JavaScript that we wrote in our script.js files or in these files goes to this whole uh, compiling, interpretation, optimization, and then it gets converted to the machine code. So this is the like basic introduction how a V8 engine is run, how it executes the our JavaScript. This what we can see here also, V8 engine is was originally created as a part of Chrome, but considered as a significant important project because as we all know it's like powering the Chrome today. So it is also splitted, and they started worked on it as a full time, like they started it taking as a serious projects, and now we have this fast execution of this JavaScript, and such so many websites like Gmail, Google Drive, and Maps are also powered by this V8 engine. So later on, if you know about Node.js, it is also a runtime environment for JavaScript on server side. Uh, its creator, also named as Randall, was also looking for something easy, something powerful, and event-driven website. So they started JavaScript and V8 engine as their base for Node.js. So that's how these all came into the picture. Okay. Now, what is the benefits of V8 engine is V8 engine compilation to optimize the code, used code very frequently. So what is just-in-time compilation is, so as we know that ignition converts this into the bytecode, and then we have this turbofan, which is a compiler which creates this optimization. So like if we have some reused code, we have a code, for example, function we have a function which is used in so many places, like we have this function is used in so many places that turbofan is so intelligent, like it's made in such a way it will understand that this function is being used in so many places uh, in the code. So it will optimize this in such a way that whole optimized code becomes more optimized, more fast, which is on a just in time compilation basically. So it use this all intelligence which is created by Google in it to increase the speed of the code more more uh, ठीक है? So now understand enhanced user experience. As we know, we have so many interactive websites. If you go to a website called awards.com, there are very beautiful and interactive websites, and that are basically all made using JavaScript, and that's how this all came into the picture. So now understand why React was created. So first of all, before going to the React, let's understand some minor concepts of JavaScript, how it's all done, and we will get into a practical session also. So yeah, let's start with first how JavaScript works. So the first part of JavaScript execution is the execution context. So as this V8 engine does all this optimization and all the stuff, it is responsible for creation of this execution context, which is let's write it here also. This is known as the execution context. And this execution context has two things, two parts basically. What so first is the memory, memory phase, memory part, memory phase, you can say memory phase, and other is the code phase. So what happens is, if you write a program, let's write a program here as well, a little, like we have a var a is equal to 100, and then we have a function, we can say a function sum we can say, and this function takes a, let's see, we can say it's take 2 as its there, and we have then another variable here. Okay, then what we can say, oh yeah, wait, this is not like this is like we take an n here, an n plus n, and we just do a console dot log here, and right be here. So this is a basic program. Let's also call this function sum 2. So yeah, so now what happens is, as we run this code, as we execute this code, first the memory allocation phase, which is the this memory phase, so memory allocation will happen. So as we all know, there is a concept named hoisting. So what happened is, as we execute the code, it will go to this line, it will create a variable in the memory and give it a value of undefined here, undefined here. Okay, now we have this undefined here. So as this function also have this is it is written in code, it will also get here in the memory allocation phase, and here we will have a whole function here, like whole function code is added here. So like if we run this code, first of all, if we like uh if we do if we do something like that, if we console log here, like if we console dot log on the top of the file for a, and console dot log the sum as well, the sum as well, this will print undefined here, undefined that we have, and this will print this whole code. So this will print this whole function body here. So uh, why this happens is, as the memory allocation phase is the first phase, it allocated undefined to our variable and allocated the whole function body to this function. Okay, now we will shift to the code phase. In code phase, as this line get executed and it sees that this variable a is of value 100, so this undefined will be shifted to 100. So we will have 100 here, and then it will go to this function. So as we are calling this function sum2, now how function will run is, function will make their own execution context here, which will have the memory phase, same memory phase, and same code phase. Now as we move here, first b will be undefined here, b will be undefined. Okay, so b will be undefined here. Then we have this n plus n, as we got the value of 2 here, so this 2 will be value of this, and 2 will be value of this and this, so we will have 4. So in code part we will get the value of b as 4, so 4 will be written here. So 4 will come here. Okay, and then we will console log it b, so it will run this console log b, and we will get in the output as the function is ran completely. This whole function will be collected by the garbage collector, and this will be deleted, and this whole execution context, which is known as, also known as global execution context, the like the first execution context is known as the global execution context, so this will also be deleted. So how it works is, we have a call stack here. In this call stack we have this global execution context, and then as we go to this function we have that function execution context. So as the function is run completely, it loads this value here, this will be popped out, and then as this is also run, there is no further execution of this will also popped out, and our call stack will be empty. So this is our call stack. Okay, and how this will know that what he has to run, we have the event loop. So this event loop checks the callback queue that we have. This callback queue will have the all the things that we that needs to be run next. So it will check this, if we have something it will add to this, and when it's executed it pops out. Then it will check again, if this callback queue have something to run again, then it will add to this, and as if everything is executed, then after that this final global execution context is popped out. So now let's understand it with the code part as well. So as you can see, we have this. Uh, Let me zoom it a little bit. One second. Yeah. Okay. Now I guess it's correct. So now we have here console log A and console log check. Check is our function. Now we see it in a browser. Now we have this hello world, and we will add this breakpoint here, and we will reload it. So you got this global object basically. So what a global object is, let's understand it as well. So what a global object is, it's basically uh, like, as we know, these are execution context, and we have that v8 engine. So v8 engine in this global execution context makes this global object. This is a global object, and in browser case this global object is also known as a window. If you have seen window, if we run this once, and if we see here window, we have this window which is basically same as we see the global object. So like if you see, this is same what we will have here as a global. So let's so like you can see, this all stuff we have here is the same we have here. So now as you can see, we didn't reach this line yet. So this var a has not been assigned this value, this 100, but still we can see a here in this global object. We have this e here. So yeah, wait, let me zoom it out, zoom it in a little bit. So you can see here we have this a as undefined here, and if we see, we will have this check function also here. So this is what is the memory allocation phase. So it is assigned undefined and assigned check here as a function. So now if we run this, let's go above and go here. So now if we see here, in console log, we can see undefined is printed, and we can see our whole function is printed. So this is how this global execution context is hoisting works. So hoisting is basically not like someone if say like someone if say that the code part goes to the top of the file. That doesn't like really make sense. This is the thing that makes sense, like due to this execution context, this global execution context, these variables are created in this way, and this all happens. Also here is what catch that we can see, like if we have let or const rather than var, we will have them in a different context. So if we say let c is equal to 200, and we will do a console dot log c, and if we save this and if we rerun it now, see, C is in a different space. It's in a different space named as script. So this is how let and const is different from var. So basically let and const will have a different space than the global object. So they will be not be a part of global object, they will be part of this script, and here we can see the value is unavailable. So what happens if we go to this console log c, we will see an error, and that error say cannot access c before initialization, which is a reference error. And this is basically due to, as it is not a part of this global, it is a different space, we cannot really access it in the same way we access this. Okay. So also there is one more thing in functions. If we like create a function like var g is equal to, like if we create a we can say arrow function, basically arrow function, like if we console.log high here, and if we do console.log g here, save it, now we will see a different thing as well. So as we will move to this g, we will came to know that g is not saved as we can say function. Basically it will be saved as variable. So if we go down here, if we can see g somewhere here. So yeah, here we got this g which is undefined, because as this is an arrow function and it is assigned to a variable, it will act like a variable only, and we will get this undefined. So if we get this um, I guess we should, so yeah, we should first comment this out, and we will get error, and we will refresh it, we will run it. So we will get undefined here for this g also. Okay. So this is how hosting works majorly, mainly how hosting works. So this is a deep concept that you all needs to understand completely. There are more in this. Let's go to the React part now. uh, as time is a little short, so I wanted to also tell about scope and lexical environment as well, but we will continue it later on. So let's go to the React. So why React was created? As we all know, uh, if we write a normal HTML, CSS and JavaScript code, we cannot scale it up to a large level without using any framework, any library, or any this kind of stuff, because uh, that is not really scalable for large application. Like you have to uh, make duplicate codes, and you have to do a lot of these kind of stuff. So that's how React, which is a JavaScript library, came into picture. And there is a difference between a library and a framework. So React is a library basically, And if we see Next.js, if you have heard of Next.js, it is a framework based on React. So basically the difference is that library does not provide you a lot of things in itself as a whole, while framework will provide you everything like routing and management of stores and all these stuffs inside it whole, like as a whole it provide these kind of stuff. So let's understand uh, React. So basically React was developed to address the complexity of building dynamic and high performance websites. So basically Facebook or Meta, there were a developer team which make this React, and that's how it came into the picture. So the main feature that React have is a component based architecture. As we all know, there is a principle named DRY, which is do not repeat yourself. So what it means, it if you have a code part, do not repeat your code in your whole project, because it is very inconsistent or very like not a best practice. So React has a component based architecture in which we can form these components like we have a button, we have a header, so we can reuse that component in various places rather than rewriting that component. Other than that, it has a virtual DOM. So let's understand a little bit about DOM. What is a DOM is? So DOM is a document object model. So what it is a like a tree like structure. If we have this HTML tag, then we have this head tag. This head will have its properties. We have then body in this whole. This body will have its property like a p tag, h1 tag, these kind of thing. It is like a tree representation of a DOM. Okay, DOM. So what React makes it where it came into picture in this, it creates a virtual DOM. Virtual DOM is basically exact copy of this in React code itself. Like we don't have to care about it in the code ourselves. It is already being written, all the algorithms is being written, so it will form this whole tree. Like we have this whole tree, exact tree of this DOM that we have. This DOM will create the exact copy. And there is a thing, there is an algorithm that is already written by Meta or Facebook, we can say, which is known as React reconciliation. React reconciliation reconciliation Also, it is upgraded to now fiber. So this is a re-implementation. This is basically a re-implementation of this reconciliation. So what this algorithm does is, this will check how this virtual DOM is different with the actual DOM. For example, if we see here, for example, if we have a h1 tag and we have a like full DOM here, and virtual DOM is also this h1 tag, and somehow what we done is, somehow we dynamically in React we dynamically change this h1 state to a p tag, like a p tag, or we change the content of this, like we change the content of this to something else using the states and all that stuff. Like we will go to the state as well for a little introduction of state as well. Rather it is a another concept. So as this content is changed, this React reconciliation or React fiber will check which part of this virtual DOM is changed and which part is different. So like as we change this to p or change the content, it will re-render this whole actual DOM and will paste the changes. So our real DOM which we have in the browser, will look like this virtual DOM with the p tag, we can say. So this is our virtual DOM, and this virtual DOM will be converted in this real DOM, will be like this will be re-rendered. Okay. And so other part that we have after the virtual DOM, we have this declarative syntax also. Like there is two types of syntax that we have: imperative syntax and declarative syntax. So React has a declarative syntax which helps the developer to describe the UI based on the current state, simplifying the development process and debugging. So what basically this means that they allows developer to give the like the JavaScript know what to do. So like they have this declarative approach. So now we will go to the React syntax once. So in this React syntax, if we can see it, so we have two ways of React basically to use React. One is by using just this CDNs. As React is a library, we can just use this CDNs in our code. So first of all, we have this React 18, which is the core implementation of React. Then we have this React DOM. So this React DOM help us to use this React core library in our browser. There is also implementation for Android apps, and it is known as React Native. So it helps this core library to use its functionality in Android, which is known as React Native. And now we have DOM for the web implementation. So a React code will be look like this in this script, in this HTML code basically. If you use a different way, which will be cover later on also, that has a different syntax. Like syntax is same, but they have a different folder structuring that we will have. So yeah, in this we've formed this function which is app, and in this we have this state. So basically state is uh, like we see virtual DOM, we make this state to store a value in this context, so that we can, while re-rendering, we can just uh, check what our state is. So basically it's like a local memory for this React, local storage for that, so that we will have this state, these values as persistent basically. Because if we like write something like var, basically if we write const a is equal to 100, while re-rendering this will basically can be vanished. So like to persist, we have this state which is made using these hooks are an advanced concept. We will study about it later on in later sessions, if we have any later sessions. So now let's understand this. We so this use state, this state that we have gives us these two things, which is one. First, this is a variable that will have the value, and this is a function which is basically used to manipulate this variable. So now if we see, we have this in this return we have this div which is known as JSX. So if we see JSX, uh, this JSX is the like the syntax of HTML inside JavaScript, and this JSX help us to render the HTML written inside the in the JavaScript to the with the help of React to the browser. So this is a JavaScript uh, extensible, as I can remind. This is named JavaScript extensible. You can guess search it on Chrome also. So this is what JSX is called. So as we have this in our h1 our p tag, so now we can see here we are using this variable, which is basically we can change dynamically after clicking this button. Let's see this into action once. So we will have this h1 tag, this h1 tag we will have. Then we have this to button. If we increment it, we will have this counter incrementation. Okay. So how this works is, now if we see here, we will have this actual DOM implementation. In this DOM we have uh, like this h1 tags, this all kind of stuff, and we will have like this counter variable here. We will have this count here, and its value is 0 first, and this is a real DOM, and that we have a virtual DOM. So this virtual DOM will be the exact copy for the while uh, count as 0. As we clicked on the button, like we have the button here with the button to increment. So this is a plus plus button. Okay, and we have a button, so button for negative negative, we can say it's a negative negative button. And when we click here, like in this button, this count value is increased by 1 and it will become 1. So now as the virtual DOM and the real DOM has the difference, like this is count 0 and this is now count 1. So here React Fiber or reconciliation React Fiber, we can say, React Fiber will check that our virtual DOM is changed and the count value is increased. As count value is increased, it will render this count to this real DOM. This virtual DOM will be copied here, if you can say it's copied here, and this value is also increased by 1. So now it will become 1, and that's what we see in here. If we decrement, we will have this counter as 0. So this is how it works. And we have these two things. React DOM that we see, React DOM helps us to create this element in our browser. So it will get this element id root that we see, uh, like it will, like we have this div here which is id is root. It will get this element with id root. It will get this element by this id root, and then in this root it will render this whole application. So basically it will render this whole, if we see this whole div inside this div. So this is how basically React works, and this is what is the implementation of React and introduction to React. If you want to like use React in the major way that is used nowadays, you can use this white. We can see, so this Vite has this command, like this is a view command. We can just, yeah, change this view to React, and we can create this React template. And in React template, in this whole React folder structuring, we will have a lot of things, the things that for added for the more optimization of this code, more things that we have, more performance boost. And this is how React came into picture, how React works at a start. And this is how you can use it. There is also an implementation with the CRA, which is create React app, but it is a little outdated. So you can use Vite because it's more optimized. It is more faster than the CRA version of that React app. So yeah, that's how it all works. And as we already see component based architecture, we can reuse the components here and there. As you can see that app function that we have, we can create that app function in different files in the major implementation of the React that we create from this YT or the CRA that we have, and then you reuse it anywhere else in the code. So here we can also see that it makes code modular and easier to maintain. We see virtual DOM, which is a in memory representation of the real DOM and updates the part that changes. So rather than re-rendering whole UI that we have, whole UI, as we already see, the short part that the counter part is updated, it will update that only, that part only, rather than updating whole DOM. So it's very smooth. It is a like a good performance boost. Then we have declarative UI, like we already saw. We just command it what they have to done, and that's how it is done. So yeah, component based architecture, like if we have this header, it is a component, we can reuse it anywhere. We have state change, we have like clicked on that button, the state changes. This is how it all works. So what does the future hold and how do we proceed? So there are a lot of advancement in React also, like React 19 has came into picture, which has a lot of hooks kind of things. Hooks are basically, as we see, use state. Hooks like provide us a more functionality over that React to do a lot of stuffs. Uh, like there are use state, use effect, there are use memo, use callback to increase the performance of our project that we have, that the code that we have. So these kind of stuff. So yeah, that's all. That's the end. And yeah, if you have any doubt, we can take the doubts, and also you can connect with me on LinkedIn. There you will get my topmate as well. Topmate, you can connect me on that as well. So yeah, that's the end. uh, Now we can take queries, I guess, if you have any.
Okay, thank you.
Thank you so much, Mr. Yakshit, for an incredible and enriching session. I'm sure everyone here has gained valuable insights into React.js and its potential to create stunning web applications. And also, if anyone has any doubt, the chat is open and you may ask your questions. We will take it for 5 minutes. Feedback form will be shared in the chat box and you can fill it, and from there you can have your attendance marked. If anyone has any doubt, you can write it on chat and we will address it. If not, we will close the chat in 2 minutes. Okay, so if anyone has any doubt, they can forward it to Coding Ninja's CUIT and we will address it and we'll share it to the Mr. Yakshit. So thank you, Mr. Yakshit, for this incredible session and for sharing your knowledge and helping us see React.js in whole new light. I would also like to thank you, the Department of Computer Science and Engineering, for organizing this insightful session, which has promised to be a lot helpful. I hope today's session has inspired you to dive deeper into React and take your web development skills to the next level. Have a wonderful day and happy coding. Thank you, Mr. Yakshit.
Thank you.